Alright, so welcome to Chapter 5. We are going to jump back and do a little bit of derivatives now that we've learned about integrals, because we learned something with integrals that we need in order to take some derivatives. So that's why they end up jumping back and forth, is because we need to see a little bit of both in order to approach this next set of derivatives. So we're going to go ahead and take the derivative of the natural log. I'm going to give you a few seconds to go ahead and copy that down. Remember, if I did go too quick, just hit the pause button. So we're taking the derivative. Remember, d over dx stands for the derivative of this natural log. And the derivative of a natural log actually gives me the integration of d over dx from 1 to x of 1 over t dt, which will give me 1 over x. And you're probably thinking, you're probably saying, hey, wait a minute. These letters here and here and here and here, they don't match up. We're going between x and t and then going back to x. What's going on? And we talked about something like this towards kind of the end of Chapter 4, which we used to take the integration of something by changing the letter. Do you remember what that was called? When we change a letter, we're going to use u substitution here. And if I change that and I use u substitution strategically, it gives me this, where the derivative of the natural log of u is equal to 1 over u times the derivative, or which can be simplified to u prime over u. Another thing that we've seen for u prime is just the du dx part. Remember, these mean exactly the same thing. So essentially here, we're going to do some basic derivatives. But before we get going too far, we need to know the next properties. We've seen these before. So we're going to go ahead and refresh our memories. Natural log of 1 is 0. If you have multiplication going on in a natural log, you split it with addition. So very similar to our exponent rule. Anything to the 0 is 1. If you have multiplication, you just add them. If you have division, it's a subtraction. And then the one that's a little bit different is a power becomes a coefficient. So again, we've talked about these earlier in the year. You've seen them before, but we needed them in order to be able to continue going on with our notes today. So first steps first. Let's go ahead and take a basic derivative of the natural log of 2x. So when I have more than just the natural log of x, which I have here, I have the 2 with him, I'm going to have to go ahead and use that u substitution that we talked about. And we know we start by saying, hey, what is the thing that I think that I'm going to let u be? Well, when we did use substitution with our integration, we needed our derivative. We're going to go ahead and just throw our derivative into the mix. So if I let my u be whatever I'm taking the natural log of, so in this case 2x, I'm going to go ahead and take the derivative of that guy. And the derivative of 2x is just 2. So the derivative of natural log of 2x is going to give me the derivative, which was 2, over my original inside part, or whatever I'm taking the natural log of, which is 2x. And then we ask myself, can I simplify? And in this case, we can. My 2 over 2 will cancel out, and I get left with 1 over x. Let's try a little bit of a harder one. I'm only saying it's a little bit harder because it has an expression with 2 terms instead of 1. So I'm going to go ahead and approach this the same way. I'm going to let whatever I'm taking the natural log of be my u. So I'm going to have my u be x squared plus 1. I'm going to go ahead and take the derivative of that guy. Thank you, computer. Which will give me 2x And according to the nice, lovely formula that we talked about 2 slides ago, the derivative of this guy is just the derivative of the inside divided by the original thing on the inside. And I cannot simplify this. If it was reversed, I would try to, but I can't. So that's just my answer. All right. Moving on up a little tiny bit with our, I guess you could say, difficulty level. If you notice here, I only have the natural log of my x, which is pretty, we like those because we can see the answer right away. However, we're being multiplied here, so we need our product rule. Okay, so product rule tells me I have the first. So in this case, my x, because that's the guy out front, so there's my first term, times the derivative of the second. Now, we said that when it was multiple things, we let u and stuff be whatever's inside. But when it's just by itself, if I go way back to the beginning, so yes, I jumped a couple slides, the derivative of just, switching colors here, the derivative of this guy is just 1 over x, which I like that. It's one of the things I just need to know. So the derivative of my second piece is going to be 1 over x. So I have the first times the derivative of the second, plus the second, which is my natural log of x. And same thing when we dealt with sine, and cosine and cotangent and secant and all that stuff. If there is only one term here, you don't necessarily need the parentheses around it. But if I were to, say, talk about the example before, that's why I had parentheses about it. Because it has the addition and it can have addition, subtraction, all that other stuff going on. And we need to indicate that all of that's being taken the natural log of. So again, that's why we have those parentheses. So if you want to put them, you're more than welcome to. If you don't want to, you don't have to. And then we're going to go ahead and take the derivative of the first guy. And we know the derivative of x is just 1. Okay, so let's go ahead and simplify this up a little bit. X times 1 just gives me x. I have x over x plus natural log of anything times 1. It's times 1, so it's itself. X over x will reduce down to 1. So I get 1 plus the natural log of x. All right, next problem. Now this one, I have a quantity to the third power, which is not the same thing as, this is the second one that I just wrote is saying that I'm taking whatever that x value cubed. The original problem tells me I'm going to take the natural log of that, get an answer, and then take that answer cubed. So they're 2 different problems. So please, 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 there's one like this on your homework. Don't get it confused. The reason I say that is I did for like 2 seconds. I was like, wait a minute, I'm forgetting something. And I went back. So when you look at the answer key, it's probably why you see whiteout. So because this thing is quantity cubed, we're going to use our chain rule. So chain rule tells me I take the power and bring it down. Leave the inside alone. And then I reduce the power by 1. And then I go ahead and take the derivative of the inside. And the inside is just my lovely natural log of x. Natural log of x we talked about is just 1 over x. So I'm going to go ahead and simplify this guy. I'm going to have a fraction because I have a fraction above. So the only thing that's going to stay on the denominator is that x, and the numerator will be 3 times the natural log of x quantity squared. No, my x's do not cancel out. I'm taking the natural log of something. It's just like if I were taking the sine or cosine or tangent of something, it just stays the same. Just stays in there, does not get to cancel out. this next problem, we're going to have to use those properties that I talked about in the second slide. So you're going to want to jump and kind of refresh your memory here for a second before we start this problem. Okay, we can't take this all in one giant scary looking thing. So we're going to go ahead and simplify it because well, technically we're going to be expanding it because when I expand it, I actually simplify it because I get my terms into smaller pieces. So I want to take a look at the big key factors here. I have a fraction and fractions division, and I want to split up that division by using my rule, which tells me I can go ahead and subtract. So I'm going to take the whole top minus the whole bottom because I can split that up first versus splitting up the multiplication on top because of the fact that it's not going on to every piece, whereas the division is working with the entire problem. So I have the natural log of x times x squared plus 1 quantity squared minus the natural log of, and we know the square root is to the what? 1/2 power, good. So when I write this one, I'm going to erase the square root and I'm going to write that 1/2 power because I want things in terms of powers. If you notice, we have a power property in those properties, so we want to do powers. So again, something we've used all year. Square roots, 1/2. Okay, now I'm going to try and simplify the pieces if I can. In this first one, I have multiplication going on, and I can pull apart multiplication with addition. In the second one, I just have a power. So we're going to hold on to him for a second, and I'm going to do all the powers at once. So because I have that multiplication, like I said, going to pull it apart with addition. And since I only have this little guy being multiplied by this guy, I have the natural log of x plus, and when I pull it apart, each term gets a natural log, just like I did above in blue by splitting it with the subtraction. So the natural log of x plus the natural log of x squared plus 1 quantity squared minus the natural log of 2x cubed minus 1 to the 1/2 power. So okay, pulling apart as much as I can. Since these guys are all now to powers, I can't split those up. They're not holding together with multiplication. If I wanted to expand even more and have that there, I could, but it'd make my life a little bit more difficult. I could do it with the squared. I can't really do that with the 1/2. How do you multiply? How do you put a quantity of a 1/2? It just doesn't work. So what we're going to do now is use my properties of exponents by bringing those in front of my original term. So the natural log of x is going to stay the same for a moment. I'm going to bring that 2 down. So it's going to be plus 2 natural log of x squared plus 1 minus, I'm going to bring the 1/2 down, the natural log of 2x cubed minus 1. So I'm getting rid of those powers by making them into coefficients. Excuse me. Next, what I'm going to do is I'm going to start actually taking the derivative of this guy now that I have it simplified in easier terms. The first guy I can see does not have anything going on with him. He's going to be easy. The second guy, I need to do my u stuff. So I'm going to need a u and a du. So I'm going to go ahead and say my u is whatever is in the middle, or whatever I'm taking the natural log of. So x squared plus 1, not 11 plus 1. Come on. Okay, and then my derivative of that is 2x. And then I notice, again, on my last term, I'm going to also I have more than just an x, so I have to have a u here, which again is going to be whatever is on the inside, and the derivative, which is 6x squared. So let's go ahead and take the derivative of this guy. Different color. The derivative of the ln of x is just going to be 1 over x. I think I'm on my face at this point. Ooh, good. Okay. Not yet. Plus, when I take the derivative of the natural log of something, on top will go my pause. Let me rewind. My coefficient is there. My coefficient needs to come down as well. So we have 2 times 2x over x squared plus 1. Because my derivative goes on top, the inside piece goes on the bottom. Minus 1/2, because again, coefficient of 1/2 comes down. The derivative on top, which is the 6x squared, over 2x cubed minus 1. And then I have a couple simplification parts I can do, so we're going to go ahead and simplify that up a little bit. So the 1 over the x stays the same. That has nothing going on. That's not going to change. I have to multiply by 2 on top, so I get plus 4x over 2x. Oop, not 2x. I need to make that smaller. There we go. X squared plus 1. Now on this one, I'm dividing by 2, and I have a 6 on top. 6 divided by 2 will give me a 3. And then I multiplied by 1. Anything times 1 is still itself. So minus 3x squared over 2x cubed minus 1. And that's as simplified as that guy can get. And that's my answer. This one is not as bad as the one before, because if you notice on top I don't have any multiplication going on. So I want you to try and get this one. I want you to pause it, do it on your own, and then I want you to come back and check your answer. Oops, I put my parenthesis too early. Alright, I hope you got the same answer that I did. Something that I was thinking about as I was going through this problem is a question that might have occurred of why isn't my x, my 1/2 negative if he's on the bottom? Well, when I'm dealing with a normal, regular function, you're correct. If I did not have that natural log there, cover it up for a second, I just was told to take the derivative of this function, you're right, I would take that to the negative 1/2. However, because it's specifically the natural log, and I have those magical powers, or excuse me, these magical properties that tell me specifically when I subtract, excuse me, specifically when I'm dividing, I can make it bigger with that subtraction sign. That's why that 1/2 doesn't get the negative. That's why he stays a positive. Okay, here's homework. Have fun.